All right, so when we did the annuities, compound interest, the way that interest works was we had $1 in set amount, and we deposited that in the account. And every time we deposited that amount in the account, did we do anything else to it, or did we just let it sit there? We let it sit. There was one deposit. That deposit stayed in for a set period of time, and maybe it compounded monthly, yearly, semi-annually, whatever the case may be. But it compounded a set number of times in equal periods of time based off that original amount that we put in. But annuities that we're talking about today, we're making equal deposits in equal intervals. That's more commonly what people do. They have these retirement accounts, and what they'll do is they'll say, okay, every month from my paycheck, I'm going to take $100 and deposit it straight into this account. Or every 6 months, I'm going to make a lump sum deposit of maybe $500, whatever the case may be. So when we talked about compound interest before, it was money goes in, money sits, we don't do anything with it. Well, today, we're talking about this situation where every week or every month or every year, whatever that time period is, we deposit an equal amount of money every equal time interval, whatever that time interval is, and that's totally up to you. But with banking and this idea of direct deposit, it makes it really easy for us to regularly save money. And hopefully what you're going to find out today is exactly how much money we can make and what a big difference that makes over the course of retirement and over the course of the interest that we can earn. So yesterday we talked about two different options. Option number one was taking a value out of the table and doing a multiplication. Option number two was we actually used a formula with exponents to come up with an answer to whatever is going to be in the account. Well, today we have two options again. And just like yesterday, option number one involves us pulling a number out of a table. And today, that table is going to be on page A12 in your book.
Something really funny.
What do you got?
You're supposed to say the account earned 6% in years. And I copied years instead of earned.
Nice. Those are the nice little surprises that you just never pick up on.
No, I think it's funny because typically when I write, I correct myself while writing, and I just read that and figured out over mine and
and you just wrote down.
I just figured it was like a math term.
Man, you guys gotta warn me that I stop discussion on video. Now I look like an idiot. Okay, so two options. Option number one, future value. This is how much money is in your account at the end of whatever the time period is. Maybe it's 2 years, maybe it's 10 years, maybe it's 30 years. However long you decide to deposit money in that annuity. But the future value equals the amount of whatever you deposit. So that's not, let's say I deposit $500 a year for 6 years. That's not 500 times 6. That's just the $500. That's what we deposit each time we choose to make a deposit. And so what we're looking at is I take the amount of that deposit multiplied by the future value of the dollar. Now that future value of the dollar is based off of two things. Number one, it's based off of the interest rate per period. So we talked about this a little bit yesterday. Something earns 6% every year, so 4 times a year. I divide that 6% by 4, and I get 1.5% per period. Remember, those things are going to be in decimals. Second thing it's based off of is the number of periods that there are in general. So if something compounds 4 times a year for 5 years, how many total times will that compound over the 5 years? 4 times a year, 5 years. What do I get? 20 times, exactly. So, based off of those two things, and based off the number in the back of the book. So we'll start with a book-type problem. We'll start with the table, option number one, with the first example, and then we'll slide over to the second situation, and we'll see what the difference is going to be between the two. So when we look at our first problem, it says Phil deposits $500 quarterly. Quarterly is how many times a year?
4.
4 times a year, so that's every how many months?
3.
3 months, good. All right, so every 3 months, Phil's putting $500 in an account. And this particular account earns, not years, 6% compounded quarterly. And what we want to know is, number one, how much money is going to be in the account at the end of the 2 years. Number two, we want to know how much interest was earned over those 2 years. So we're going to start with this idea of coming up with those numbers out of the table. We want to come up with what the interest is per period, and we want to come up with how many periods there are over that given amount of time. So
3 times 500 by 6% or 8 times.
we could do that, but do you want to compound that? You want to do 8 different multiplications to get your number?
No.
No, not necessarily. Maybe there's something faster. So we look at it and we say, okay, $500. Well, we're not using that yet, because what we need is we need to know what the interest rate is per period and how many periods there are. So,
periods.
How many periods are there?
4.
So I divide 6% by 4, and what do I get?
But in 2 years it's going to be 8 instead of 4.
Sure. But we're just looking at interest rate per period, and so there's 4 in 1 year. So everything's based off 1 year. Then we slide from there. So what's 6 divided by 4?
2.5. I mean 1.5.
1.5%. So every time my account compounds for 2 years, I'm going to earn 1.5% interest.
That's actually wrong. It's like 1.3 or something. I don't know.
I think it's 1.5.
Oh, really?
Yeah. Anybody? It is 1.5? Yeah, okay. So 6 divided by 4, I get 1.5%. So then the second thing we need to do is we need to look at how many periods are there. So how many times did it compound a year?
2. Wait, what?
How many times did it compound per year?
4.
4 for how many years?
2.
Exactly. So 4 times 2, I get 8. So it tells me my number in the table is going to be based off of 2 things. Number 1, it's based off the interest rate per period. Do I know what that is? What is it? 1.5. Second thing, it's based off of how many periods there are over the entire life of that annuity. Do we know how many periods there are? 8, exactly. 8 periods. So once we have this information, I can go to my formula. My formula tells me my future value, because I do need a future value, equals the amount of the deposit times the future value on page A12. So if you want to go ahead and open up to page A12, I want to make sure that everybody can find this value in the table before we move forward.
Okay, I found it.
A12. So it's in the back. It's in orange. In the appendix. And it'll be the 12th page. So it's right after the page we used yesterday.
Well, page 812. What's that? I found it.
Alright, so when we look at our formula, it tells me future value is equal to what times what? Future value is equal to what times what? Amount deposited times the future value of the dollar. Do I know how much I deposit with each deposit? How much do I deposit each time? $500. Multiplied by the future value of the dollar. Now on page A12 in your book, that future value is based off 2 things. It's based off the interest rate per period, which is 1.5%. It's based off of number of periods, which is 8. What number is in that table at 1.5%, 8 times? So N along the left side of your table is going to be 8. 8.43284. All right, 8 point what? 43284. So what that's telling me, because yesterday we had a value of the dollar, and we took that value of the dollar and multiplied it and said, this is how much is in there at the end of the year. Well, today, this is how much each dollar that I deposit is going to be worth at the end of the 2 years, assuming it compounds 4 times a year, 2 years, 8 total times. What do I get when I multiply 500 times 8.43284? What's that number going to be?
Mm-hmm. Everyone used to calculate it at once.
Oh, he's got it going.
4,260.
And 42 cents? Why doesn't it seem right? Seems like a huge number. But keep in mind, this $500 is what? The deposit. How many times did I deposit this? There you go.
No, you deposited it one time.
I deposited it every 3 months for 2 years. So I deposited that 8 separate times.
Okay.
So my future value at the end of the 2 years, so I make 4 deposits a year for 2 years. At the end of the 2 years, it's $4,216.42. But my question is, how much money did I deposit originally? Because when we ask the question, it says 2 things. What's the future value? What's in the account after 2 years? $4,216.42. But it also asks,
5,000 how many times?
how many times?
500 how many times?
How many times? You tell me. 8.
So 5 times 8.
Okay? So my formula tells me future value minus total amount deposited is what I'm looking for.
We made 260.42. Right? You're wrong.
I think you're good.
Yeah, 8 times 5 is 40.
8 times 5 is $4,000. So when I take my 4216.42 and I subtract my 4,000, I'm left with 216.42. Does that seem like a better number? What do we think, John? Does that seem like a better number? 216.42? That seems a lot more realistic. But that's what's tough about it, is we use this 500, whereas when we talked about it yesterday, if this was 500, we would say $500 is all I put in there and I left it in there the entire time. This way with an annuity, remember, it's equal deposits, so $500 in equal intervals every 3 months over those 2 years. So we look at it and we say, okay, they deposit $500 every 3 months. Well, what's $500 over 3 months, really? It's like $165, somewhere right around there a month. $165 a month is pretty easy to save. So that's doable. Very doable.
Have you been drinking that water all week?
Bring like 4 bottles.
Alright.
Well, no, because someone had drank that water, and I blew sex on my second hour, and someone put a water bottle of that same brand in there, and it got like all over the place. It was ridiculous. I was mad.
I drink my water.
Your light flashing before your eyes, didn't it?
No, I
She was
was
about to
like,
come over the desk at you.
yeah, I know. I was like, wait a minute, what's going on?
Please, I promise, it wasn't me.
I think this is Target brand.
Alright, the shot to Target.
All that shit.
Who was
I
it?
like Target too.
Who was it?
Target the shit. It is.
Alright, thanks for that.
I mean, you
We're
can
gonna have
walk
to cut
in,
that
go to the
piece out.
right, buy a Slurpee, a pretzel, and some popcorn.
Pizza, too. They got pizza.
Yeah, Pizza Hut.
No, they got
and
like
a
those
Starbucks.
breadsticks there.
Oh, yeah.
Alright, so
It's like
before we
a
totally
paradise.
lose everybody, let's get back on track so you can see option
We
2.
got the same color as Target. What's this?
So when we talk about these different options, when we talked about 2 options yesterday, I said I don't care which option you use, you can ignore the directions. Find the one that works for you, stick with that option, and continue to use it. So that's option number 1. Seems pretty realistic. 2 years, we made $216.42. Not a ton, but when you think about the fact that you're only saving about $165 a month, and you're only doing that for 2 years, hey, I'd be happy with an extra $216.42 that I didn't have to do anything to earn, other than save my money that I would have saved anyway. I mean, It's a win-win. You're getting free money out of the deal. You just got to leave it in there long enough and make those regular deposits to be able to make it happen. So when I look at my second example, it says Diane deposits $500 at the end of each month. So Diane's depositing a hefty chunk of change. $500 every month. And it says the account earns 6%. It's compounded monthly. So start with compounded monthly. How many times a year? What? Exactly. 12 times a year she's putting in $500. But at the same time, 12 times a year, she's also earning interest on what she deposited. So pretty good situation for Diane because number one, she can afford $500 every month. Number two, she's earning interest 12 times a year, whereas Phil was only earning interest 4 times a year. Less interest, but more times it compounds. So we're going to see what this does, but she deposits $500 at the end of each month. Account earns 6% compounded monthly. Number one, what's the future value?
Wait, are we still using the first option, or are we using?
We're going to go to option 2.
Okay.
So the only thing you have to do with option 1, and that's good that we identify which one are we going to do. You got to come up with this 8.43284 out of the table on page A12.
We gotta find that, but it's gonna be a different number, isn't it?
That's going to be a different number now.
Why?
Yep. Well, because we're using an entirely different method, so we're not even coming up with this number. Here they gave us what that number was, the value of the dollar. Over here we're using the bottom formula. So the things I need to know is how much did I deposit, what's the rate per period, and how many periods are there. So those are going to be my calculations. So when we look at this, what we want to know is how much interest did she earn in 15 years? So for 15 years, Diane is depositing $500 every month, and it's compounding 12 times a year. So when we look at this, our formula tells us, I need to know 3 separate things. I need to know how much she's depositing. What is she depositing each month? $500. I need to know the rate per period. Do I know what the rate per period is? How do you know? Exactly. So per period, 6% divided by 12. Sorry. So that's going to give me 0.5%. So keep in mind, yes, this interest rate is lower. Here I was getting 1.5% per time it compounded, per 3 months, per quarter. Over here, I'm getting 0.5% per period, so considerably lower. Well, we're going to see what happens to this number, and we're going to see why we would definitely rather have this option than that option. The compounded monthly versus
Why would you
the
rather
compounded
have this
quarter.
one?
Yeah, we'd definitely rather have this
But
one.
now don't we take
Wait, using
12
this
and times it
option?
by 15?
Well, not necessarily the option. So the option's number one. Give me 1 second, Zach. Options number one, I can use the table. But what did we talk about yesterday? What's the downside to using the table? What might happen? Okay, could lose our place and could lose the number, absolutely. Give me another downside.
Percentage should be higher.
Percentage could be higher than what?
What do we go up to? 2 point something?
Okay, so in the table we only went up to 2.5% or 3.5%, whatever it was. Well, what if a situation like this, I only earn 0.5% interest? Well, it started at 1, so is 0.5% even going to be in my table? Probably not. So what I have to do is come up with another method to do that, and that's going to be option 2. So when I look at this, I said, okay, here's what I need. Amount deposited, rate per period, number of periods. Do I know the rate per period? Yes. What is it? 0.5%. Excellent. Do I know how much I'm depositing each time? Yes. $500. Excellent. What am I missing? from this formula, what don't I know yet? Number of periods. Somebody tell me how I can find the number of periods.
Well, do the 12 times number of years.
Okay, so Rachel, I heard you say 12 times 15. Matt, you said 12 times number of years. Well, it's 15 years. So we're good. What's 12 times 15?
12 times 15.
Mm-hmm.
Let's find out.
180, thank you. So, look at that situation. This situation, my account only compounded. And remember, when we say compounded, what we're saying is, how many times do I earn free money? That's the way to think about it. So I only earned free money 8 times. Over here, I earned free money 180 times. And remember, after the first time, that little bit gets added to my account. So now I earn free money on more money. And then free money on more money. And every 180 times, there's more money than there was the time before. So now, look at my formula. Do I have all 3 pieces?
No.
Do I have the amount deposited?
No. Wait, yes.
Yes. Do I have how much it earns each period?
Yeah.
Yes. Do I know how many periods there are?
Yes.
So I know all 3 pieces. Let's plug it in. It tells me future value. So future value is the amount deposited, which is 500, times 1 plus the rate per period.
0.05 or 0.5.
Well, that's 0.5%. But remember, when we do percents in context of problems and calculations, we need to convert this to a decimal.
0.005.
Yes, it would. So that's 0.005.
Why would it be 0.005?
Because you move the decimal 2 fifths left.
Yeah. So I have 0.5%. I can take that 0.5 and move the decimal spot 2 places over. And now I have 0.05. That's good. So if we're converting from a percent to a decimal, you move it 2 to the left. So if I had to convert this 1.5% to a decimal, how would I represent that as a decimal? If I moved it 2 to the left.
0.0015.
Where's next to 0?
0.015.
Yes, absolutely. 0.015. Okay, so amount deposited times 1 plus the interest rate per period to the power of how many periods there are
180.
minus 1 divided by the interest rate per period. So here's what I want you to do. What comes first? Parentheses, exponents, multiplication, division, parentheses. So add 1 and 0.005. Somebody do that for me.
It's just 1.005.
Okay, so somebody plug that in their calculator, 1.005. Somebody have it for me? Okay. Now take that 1.005 and raise it to the 180th power.
I got 2.45409.
Okay. Multiply by 500.
This seems really complicated.
Okay, what's complicated about it?
This whole thing just seems really long, like a long process.
They're pretty long.
Yeah, I don't like that.
Well, it's easy to pull it out of the table. The problem is, because when you go to the bank, you're not going to get 3% interest or 3.5% interest. It's going to be like 3.61% interest. Well, 3.61, we don't have a table for it. So we got to have these formulas. Now, the downside here, the computer could do all this for me. And if you went in the bank and you asked them, if I do this, how much am I going to have at the end? The computer could do it for you. That's the downside. We don't have that advantage. What about that minus 1? So we're going to do that at the end. But did you do 1 plus 0.005? Did you raise it to the 180th power? Did you multiply by 500?
Yeah, it's 1,227.045.
Okay, did you subtract 1?
No.
Say, do that now. And tell me what number you get.
1,226.045.
So about 0.05 if we round it. And when I divide that by 0.005, what do I get? 245,209.
Yeah.
Any cents?
No.
Okay.
35 cents.
35 cents. So here's what I'm thinking about. Based off the criteria that I put forward, at the end of that 15 years, I have $245,209.35 in my account. That's a crap ton of money, right? Kind of.
Yes.
I mean, 15 years, I'd be happy if I had this much money. But we need to keep in context, how much did I put into the account? So how much did I put in each month? 500.
500 in 12 times a year, 15 times.
Okay, so $500, 12 times a year for 15 years gives me what? 90,000? So yes, I have $245,000 in my account at the end of the 15 years. Yes, I put 90,000 in. So when we look at how much interest I earned, somebody tell me, what's 245, 209.35 minus 90,000?
155,209.35.
That's my interest. So you look at this and you say, yeah, I had to put $90,000 into this account over 15 years, but look at the return you're getting on it. After 15 years, I got $155,209.35 for free, at no cost to me.
Free money.
Free money. And it more than doubled my money. 90,000, if I just asked them to double it, that's only 180. But I'm all the way up at 245, 209.35. So look at this. Let's say I did this for 30 years. That's $310,000 earned in interest. $310,000 from putting this money away every month for a set period of time. $310,000 of free money. So when we talk about retirement, when we talk about Social Security, when we talk about Medicare, when we talk about all these different options that are out there to help people survive after the age of retirement, think about it. We look at those Social Security amounts and we say they're not making much money. That's why it's so important to invest, because you know what? Diane is going to get Social Security at the end of her retirement, or once she retires. She'll collect Social Security at age 62. She'll be able to collect some type of pension from her company if she can afford to put $500 in each month for 30 years or 15 years, whatever the case may be. But think about the fact that once you retire, other than Social Security, other than pension, you have nothing coming in. you're paying expenses out with nothing to replenish that stock. Well, now if I invest like this, after 15 years, I got $155,209 to replenish that stock. So that's why investing early is important. Because when you think about it, when's the best time to invest? If I invest now, what expenses do I have, really? I have expenses on a house, I have groceries, I got a car, I got things like that. But if I have a family, what expenses do I have? I have the expenses for me, I have the expenses for a spouse, I got the expenses for all the kids. So it's harder to save money later on than it is to save money early on. So save money as early and as often as you can. Because right now, you know what? Yeah, it'd be great if I went out and bought a new TV. Or I bought a PlayStation 4, or whatever the case may be. It'd be great if I just went out and bought that stuff. But keep in mind, that's, I don't know, what? New TV, let's say it's $1,000. I mean, that's $1,000 that I could save. That I could earn interest on so that when I decide to retire, I'm not having to retire at age 80. I could retire at 62 and then start collecting Social Security, pension, and live off of my retirement. Plan early, plan ahead, plan often, do whatever you got to do, but get that money in there. Because this is free money. So before, yeah, we said, okay, $216, great, $216. That's fine. Not that much money. You could go out right now and spend $215 and still not get everything that you wanted to buy. You could do the same thing with $155, but you can buy a heck of a lot more stuff with $155,000 than with that $216. So keep those types of things in mind as we move forward. But obviously, these problems do take a lot longer. We're looking at a table. With our first example, that's option 1. Option number 2, we're using a formula. Option number 2 will work all the time without fail. There is no circumstance that we could come up with, no problem I could generate where option 2 won't work. But it is a more complicated formula involving adding, subtracting, multiplying, exponents, dividing, a whole bunch of different pieces. This right here, this method with this future value of the dollar only works if we have a percentage and a number of times compounded that we can find in that table. So keep in mind the difference between the two, but just notice annuities, equal deposits, equal time intervals. Compound interest that we talked about the last few days, that money you put in one time, you let it sit, you don't have to add to it, you don't take from it, you just let it sit there. That's our big difference between the two.